Okay, Algebra 2 students, in this video today we're going to be learning how to add, subtract, and multiply polynomials, okay? Add, subtract, and multiply polynomials. To be honest with you, this material is pretty simple. I don't think you'll have any problems with it, and it should be reviewed for the most part. Your heading for today is adding, subtracting, and multiplying polynomials, lesson 9.1. And as always, be sure and include today's date. Okay, be sure and include today's date. Alright, moving on. Our goals today are to quickly learn what a polynomial is, so we should at least talk about that. Also, I want you to know how to write a polynomial in standard form and then find its degree. Okay? And then after that, we will add, subtract, and multiply polynomials. Okay? So, if you want to see a complex definition of a polynomial, you can find this on page 465, and to be honest with you, whatever you see on page 465 is exactly what you would see in any math book, okay? So I would encourage you to quickly turn over there and take a look at it. It's right in the middle of the page in a light blue box. It says, with red letters, definition of polynomial, okay? Now when you look at that on page 456, it definitely looks confusing, but to be honest with you, that's a good, solid definition of a polynomial. However, I will agree with you that that blue box on page 456 is pretty complicated, so let me break this down and explain to you what a polynomial is. In language you can probably understand, okay? So here we go. First of all, a polynomial is, are you ready? I would write this down. I probably should have typed it, but I didn't. It's a list of terms. Okay, it's a list of terms. Now, I guess to use the word list is a little loose because you have to have at least one term. So at least one term. So it's really not a list if you have just one term. But you need at least one term to have a polynomial. So first of all, a polynomial is a list of terms. And you must have at least one term, okay? Secondly, you should have one variable. Not two, not three, one. Okay? One variable. Next, the variable exponents have to be rational, and we'll talk about that in a second, okay? And positive. No, that's incorrect. Yeah, that's right. Rational and positive. Okay? The variable exponents have to be rational and they have to be positive. That's really important. And then lastly, your coefficients. coefficient. Your coefficients must be rational numbers. They don't have to be positive. They can be negative, but they have to be rational. Now, let's pause for a second and talk about the word rational, okay? So you know what I'm talking about. Now trust me, later on during this chapter, I am going to go in very good detail the difference between rational numbers and irrational numbers. I promise you I will do that, okay? But we don't need to do that today. For today, it's just sufficient to say this. Irrational numbers, they don't repeat and they don't terminate. In other words, irrational numbers go on and on with no repeating and with no terminating. For example, pi goes on and on without repeating, without terminating. The number e goes on and on without terminating and without repeating. All of your square roots are that way, except perfect squares like square root of 5, square root of 11, square root of 12, square root of 9 would be rational, because the square root of 9 is what, guys? 3, okay? But all of these others, they're not perfect squares. The square root of 5 gives you some decimal number. It goes on and on. It doesn't repeat. It doesn't terminate. Same thing with this. Same thing with this. So that's good enough for now. Just understand that irrational numbers are kind of weird numbers. like this. You know, they go on and on. They don't repeat and they don't terminate. Numbers like this, pi, e, or square roots of numbers that are not perfect squares, okay? So that's irrational. So any number that's not irrational is then rational, okay? So that'll help. We'll get more into details. We'll get more into that later, okay? But let's review this list very quickly. A polynomial, first of all, is a list of terms. It has to have at least one term. It has to have one variable. Not two or three, one variable. And the exponents of the variables have to be rational. They have to be positive, rational, and positive. And the coefficients have to be rational numbers, okay? So that's what a polynomial is. A polynomial could be something like this. 4x squared minus 6x plus 5. That's a polynomial, first of all. It's a list of terms. Yep. Do we have one variable? Yep. X and x. Are the variable exponents rational and positive? Yep. Here's the variable exponent here. What's the variable exponent here? 1. Are they both rational? Yes. Are they both positive? Yes. Look at your coefficients. They are. Are they rational numbers? 4 is rational. 6 is rational. 5 is rational. Thus, this is a polynomial. Now, I would not get hung up too much on this definition here. I mean, I'm going to give you some on quizzes and tests where I ask you, is this expression a polynomial? But we're going to practice some of those in your homework, and I think that'll help a lot, okay? So make note of this and let's move on. I'm going to break it down a little bit and explain what this means. I just did that, so we're moving on. Now let's talk about standard form and degrees. It's real important that we do that. Alright, now here is a polynomial expression. Write this down, please. There's a polynomial, okay? First of all, this is not written in standard form. We got to talk about that, okay? So let me show you what I mean when I talk about standard form of a polynomial. Here is how you write a polynomial in standard form. You look at your variable, find your variable. Your variable is x. Now find the highest exponent of your x's, 5. So that term comes first. Now find your next highest exponent, 3. That term comes next. Now find your next highest exponent, right here. That term comes next. And then your constant term, that means the term, the number without a variable. That's always last. There we go. I wrote it in standard form. Isn't that easy, guys? So easy, okay? So it's written in standard form. Now, what about the degree? Well, the highest exponent is always your degree. So we would call this a 5th degree polynomial. 5th degree polynomial. Got it? And by the way, how many terms does it have? 1, 2, 3, 4. So we would call this a 4-term, 5th degree polynomial. Alright? 4-term, 5th degree polynomial. Not too bad, guys. Let's try another one, okay? Let's write this in standard form. Alright, let's write that in standard form. Well, first of all, find your variable. There's your variable x. What's the highest exponent? 4. So this term goes first. Now find your next highest exponent. Right here, a 2. That goes next. Now find your next highest exponent. Uh-oh, we got a problem. There's 2 of them. X to the 1, x to the 1. Well, guys, if they're like terms, combine them, put them together. So a positive 3x and a negative 6x is a negative 3x. There we go. And then your constant term always comes last. There, I wrote it in standard form. What is the degree in this problem? It's a 4th degree. 4th degree. How many terms does it have? 4. so we call it a four-term, fourth-degree polynomial. A four-term, fourth-degree polynomial. There it is. And by the way, just for kind of education purposes, is this a polynomial? Is that a polynomial? Yes, it is. The number 5 is, sure it is. Think back to what I taught you. Do we have a list of terms, at least one term? Yes, we have one term. Do I have one variable? Now, I probably should have been a little more specific, okay? I should have put probably no more than one variable. And I apologize for that small little mistake. No more than one variable. Well, yeah, we're good. We don't have more than one variable. We have nothing. Actually, there is a variable here. You could do this if you wanted to. Why could you not? You could do that if you wanted to, technically. Alright? Your variable exponents have to be rational and positive. Well, I don't have any variable exponents. Okay? Lastly, your coefficients should be rational numbers. Okay? Rational numbers. Well, that's a rational number. And by the way, guys, I know this stuff like the back of my hand. I've taught this for years. But for some reason, I just left off little things. I'm sorry. Your variable exponents should be rational. And I'm really sorry, guys. I apologize. It should be greater than or equal to 0. Because actually, when I said your variable exponent has to be positive, that would leave out 0. And to be honest with you, you can definitely have an exponent of 0 in a polynomial function. That's totally fine. So I do apologize for those two mistakes. Right here we should say no more than one variable. Okay? But you don't have to have any if you don't want to. No more than one. And variable exponents, they have to be rational and greater than or equal to 0. Okay? Or you can say can't be negative. That would work also. Okay? So yes, to be honest with you, 5 would be a polynomial. Just something to think about, okay? That's a polynomial. Because it's a list of terms and it fits all the other criteria, so we're fine. Alright, now, moving on to, should I give you guys one more example? I think you've got it okay. Write it in standard form. And then the degree is always the highest variable exponent. Of course, if you've written the polynomial in standard form, then the degree is going to be the first term if you've written it in standard form. Alright, let's move on. I hope you guys have got that okay. Alright, let's move on. Now, on to the actual math part. I'm not going to give you a lot of examples. Well, I think I give you five or six. But they really don't take a lot of time, so I should say I will not give you examples that take a lot of time, okay? So here we go. Yeah, 6 of them here. Now, look at these examples. Let's talk about them for a second and simplify them, okay? Are you listening? Do you see the difference between each of these? What's in between the two parentheses here? Subtraction, a minus sign, so we are not doing what? We are not multiplying. Here, what's in between the two parentheses? Addition or a positive sign, so we are not what? Multiplying. Do you see that okay? But here, this 12x squared is right next to the parentheses. We are multiplying. Here, the two parentheses are side by side. There's no plus or minus right here. We are multiplying. Here, the two parentheses are side by side. There's no positive or negative here. We are multiplying. We'll talk about this one later. Do you see the difference between these? Not multiplying, multiplying. Because that's the first thing you have to understand before you start simplifying these, okay? So here we go. Let's take a look at the first one. Now, are we multiplying the two parentheses? No. So here's what you do. You simply get rid of your parentheses and then combine like terms. Watch. What's to the left of this parentheses here? Even though you can't see it, a positive sign. So take the positive and multiply it through. Whenever there's a positive outside, nothing changes on the inside. There we go. However, when there's a negative on the outside of the parentheses, all of the signs change on the inside. So this positive 3x squared becomes negative. This positive x becomes negative. And this negative 4 becomes positive. And you see this sign right here? See this? It's gone. Forget about it. You took it and you multiplied it through the parentheses, it is totally gone. Got it? Very important you understand that. So let's stop and review. Are these two parentheses multiplying? No, there's a negative sign here. So what do? We get rid of our parentheses by multiplying the sign through. Okay? And then we combine like terms. So if there's a positive sign out front like this, nothing on the inside changes. If there's a negative sign here, all of the signs change. Now, let's write this in standard form. Find your highest exponent, x squared, combine those. Positive 2, negative 3, that's negative 1. You do not need to put the 1 if you don't want to. You can just put the negative sign if you want to. Okay, let's find your next highest exponent. X with the 1, there are two of those. A positive 3 and a negative 1. Positive 3, negative 1, that's positive 2. You can put the 1 right here, but you don't have to if you don't want to. And then lastly, bring down your constant term, and you're finished. So this expression right here, simplified down to this right here. Really not too bad, students, okay? Let's try another problem. Okay, the first thing you ask yourself is, am I multiplying these two parentheses together? And the answer is obviously no. There's a positive sign here, so we're going to get rid of the parentheses. There's also a positive sign here. So take the positive and multiply it through. Nothing changes on the inside. Nothing. I know what a lot of you are thinking. You're like, well, can we skip this step and just go ahead and add the two together? If you want to do that, feel free to. I try to break this down to small steps, but that's fine to do. There's a positive sign here, so nothing changes on the inside. Your positive 4 stays positive, and your positive 10 stays positive. Now, let's simplify this. Look for your highest exponent, 3. There are two of those. Positive 7, positive 4. That's positive 11. Find your next highest exponent, squared. There's no more of these up here, so bring that one down. Next, look for your x terms. There are none. Oh, there is one right here. Sorry, guys. 13x. That's a 13x, my fault. So you have one x term. Bring that down. Now look for your constant terms. Negative 2, positive 10. Combine those. Positive 8. There you go. This entire expression right up here equals this expression down here. Okay? By the way, what degree is this polynomial? Third degree, correct? Sure, third degree. Alright, moving on to the next problem. Okay, now, do we have multiplication here? Yes, we do. We're taking this 12x squared and we're multiplying it through the parentheses. So, 12x squared times x, well, there's really a 1 here in case you can't see it, so 12 times 1 is 12. X squared times x to the 1 is x cubed. There, I did it. I took 12x squared times x. Now take 12x squared times negative 8. Positive times a negative is negative. 12 times 8 is 96. X squared. Guys, watch that again over and over if you need to, please. You've got to know how to multiply polynomials, okay? This is a polynomial, and this is a polynomial. And by the way, we may as well talk about this now, okay? Take some good notes in your notes here. This is a one-termer. We call that a monomial. This right here is a one-termer. We call that a monomial. This polynomial here is a two-termer. We call that a binomial. Make note of that somewhere in your notes. This has 3 terms right here. This problem down here. We call that a trinomial. Trinomial. Okay? Now, this expression here with 4 terms. 1, 2, 3, 4. Sometimes I will call those a quadnomial, but that is a word I have made up on my own. It does not really exist, okay? But sometimes you'll hear me say that, okay? But the 3 words we use with polynomials are monomial, binomial, and trinomial, okay? Alright, let's move on. So I'm going to use those words now during the rest of this lesson. Alright. Alright, here we go. Let's take a look at this one over here. Are the two parentheses side by side? Yes. So am I multiplying? Yes. I have a binomial times a binomial. So you pick up the x and you multiply it through the parentheses. X times x is x squared. Now watch your signs. A positive x times a negative 1 is a negative. X times 1 is just x, or 1x if you want to put the 1 there. Now take your 8 and multiply it through. 8 times x, positive times a positive, positive 8x. Positive 8 times a negative 1 is negative. 8 times 1 is 8. There, I did it. I took the x and I multiplied it through. I took the 8 and I multiplied it through. Now combine like terms. I have an x term and an x term. So bring down your x squared. I have a negative 1 and a positive 8. That's a positive 7x. Then bring down your negative 8. So what do I have here? I have a second degree trinomial. A second degree trinomial, because that's 3 terms. A trinomial, of course, is a polynomial. A monomial is a polynomial. A binomial is a polynomial, okay? So we have a 3-term polynomial, or it is called a trinomial. We have a second degree trinomial. Second degree trinomial, alright? Okay, moving on. Alright, are the two parentheses side by side? Yes. So are we multiplying? Yes. We have a binomial times a trinomial. Nothing changes. You simply take the 2x and multiply it through. So 2x times 4x squared. Well, 2 times 4 is 8. X times x squared is x to the third. Add your exponents. Now watch your signs. Positive times a negative is negative. 2 times 3 is 6. X times x is x squared. Now, positive times a positive is positive. 2x times 3, that's going to be 6x. Alright, so I have taken the 2x and I've multiplied it through. Now, let's take the negative 3 and multiply it through. Now watch your signs. Negative times the positive is negative. 3 times 4x squared, 12x squared. Negative times the negative is positive. 3 times 3x is 9x. Negative times the positive is negative. 3 times 3 is 9. There I did. I took the negative 3 and multiplied it through. Now, let's combine like terms. Find your highest. That was right in standard form. Find your highest exponent. 3. There's only one of those. Next highest exponent, squared. There's 2 of those. Negative 6 and negative 12. You owe me 6. You owe me 12. Now you owe me $18. So it's a negative 18x squared. Cross those off. Next are your x terms. Positive 6, positive 9. So you have $9. You get 9 more dollars. It's going to be a positive 15. And then bring down your constant term, negative 9. And we did it. This expression way up here equals this expression here. This is called a 4-term third degree polynomial. 4-term third degree polynomial. Okay. Alright, moving on. There's something I wanted to say to you guys. I'm forgetting what it was. Okay, I remember what it was. Now I want you to know that when you're multiplying two parentheses together, like this last problem, it is totally okay to swap them. You'll get the exact same answer. Same thing with this. You are more than welcome to put this parentheses first. You would just take the 4x squared and multiply it through. Then take the negative 3x and multiply it through. Then take the positive 3 and multiply it through. You'll get the exact same answer. It does not matter what order they are in. Okay? Alright, last problem. We're finally finished. Now, when you look at this, understand you cannot use the property where you have a 1 here and a 1 here, and you take the 2 and multiply it through. 2 times 1 is 2. 2 times 1 is 2. And of course your final answer then is this. That is completely wrong. Well, Mr. Error, you taught us to do that. No, I did not. I taught you when there's one term, like 6x, where they're multiplying each other. When there's one term raised to a power, you can definitely take this 2 and multiply it through. And 2 times 1 is 2. 2 times 1 is 2. And of course 6 squared is 36, x squared. That's fine. But I don't have one term over here. I have 2 terms. So you cannot do that. So here's what you have to do. Remember, 5 squared does not mean 5 times 2. It means write the 5. How many times? Twice, right? Well, same thing here. I have a parentheses square. That means write the parentheses twice. And there we go. Take your x and multiply it through. X times x, x squared. X times 6, 6x. Now take your 6 and multiply it through. 6 times x, 6x. 6 times 6, 36. I took the 6 and I multiplied it through. Now, I have 2 like terms here. Positive 6 is positive 12x. Bring down your x squared. Bring down your 36. And look at that, we're finished. Written in standard form. I would really like all of your answers written in standard form, guys. But I'm trying to teach you the right way to do this, okay? Alright, guys. That's it. I hope this video's been a help to you. If you have any questions, don't hesitate to call or email.